Swinburne University of Technology.
Thanks, Anna. So I was asked to speak about various models for kind of e-research at Swinburne. I always have trouble with the term e-research, but I think one of the interesting things is that I was watching a TV show the other day and it says, big data is the new oil. So if you can sort of harness and understand big data, you get rich. And if we look at my own research, the kind of surveys we were doing in 1993, or starting in 1993 and lasting several years, used to record about 1 terabyte of data. And we used to think that was epic and unbelievably large, and we had 500 exabyte tapes, and we'd feed them into these little machines, and they held 2 gigs each. And now we're doing surveys that hold 1 petabyte of data. And if you look, we're going to hear about the SKA later on, and it's going to generate this kind of data every day. And so it's scary how rapidly data is being created. But if you actually read the Australian Research Council's guidelines for the responsible conduct of research, if you actually take data, you're supposed to keep it for 7 years. And you're not allowed to delete any without written permission. And so if you are on your computer and you have some data and you drag it to the trash and go empty trash, what it should do is pump out a bit of paper which says sign here or go and get a permission to delete this data. And so it's obvious whoever's come up with these guidelines doesn't actually understand how real data works, because you could generate a series of random numbers that's very large, and that's data, and then you could manipulate it and do all sorts of research on it. And we do that all the time in cosmology. We generate these random samples with various distribution functions overlaid on it. But if ever we delete it and say, I'm going to start again, we should really go and get the dean to sign a bit of paper saying we're about to delete our data, which is kind of ridiculous. So it's clear that what the practice of researchers are doing and what the guidelines are saying don't actually mesh particularly well. When I got interviewed to become the Pro Vice Chancellor for Research, the then Vice Chancellor and DVCR, as they were at the time, said, how can we do better at e-research? And my answer was, well, we could buy everybody a bigger monitor. Because at Swinburne, we used to buy these crappy little monitors that were like 15-inch, and then we would run out of disk space all the time, and you only were allowed to have 1 gigabyte of email for some reason. And I said, well, we could up everybody's email quota. And then we could put more RAM in the computer so it didn't take so long. And I actually thought, this is my answer. Because I think you really need to address these kind of fundamentals about how you work every day before you worry about virtual machines and databases and so on. But I think, to me, this isn't e-research. I think this is just commodity standard thing that everybody should have. And so I don't think Microsoft Word or Excel is really what I would term e-research. You're not going to write a grant to get Microsoft Word installed on everybody's computer. So I think, a working definition in my brain, or something that should involve a Pro Vice Chancellor as opposed to the head of ITS, is research facilitated by non-standard hardware and software beyond the mainstream. So you can't just buy it and plug it in. Although for some people you may be able to get a custom solution, and I'm not against doing that. But I think in order to succeed in many fields of research, it's about harnessing our data and understanding it. And it's not something you can just ring up ITS and say, I need a coherent dedisperser for the square kilometre array, please. Can you provide me one? So that's what I think kind of e-research is. And so I think we have kind of 2 things that are happening in the university. We have like what ITS is providing, which is your email and a network, and I think the network at Swinburne is actually fantastic, with the caveat of some restrictions that occasionally get put on it. Things like Dropbox, have a laptop that works, a printer, this is a very vital piece of e-research infrastructure. And ITS at the moment actually provides most of these things on the left-hand side. And they also provide a supercomputer. And I don't think that's kind of right in some ways. I don't think a supercomputer is standard, but they actually have a very nice supercomputer for us, and it works very well. And then I think there's sort of ITS++, which I think is sort of like the next generation of e-research tools. And this is things like supercomputers, virtual machines, easy access to the cloud, online repositories, bits of hardware that when you attach it to your machine will automatically stick things in databases, interactive tools like Huddle. If you want to go to www.huddle.com, they have these very impressive wikis and integrated video conferencing and email and commentaries and working boards, and things like telepresence is a very sort of upmarket form of video conferencing, and Swinburne has a bunch of these. We just don't have anybody to talk to. And then there's the sort of people side of it, and I've put them in red not to hide them, but because this is more of a personnel. It's a lot easier to get a university to buy things that don't require superannuation and sort of human resources to look after them. If you want to buy 10 programmers and give them a permanent contract, that's actually more of an issue. If you want a statistician to sort of give you good advice about what your data really means, that's also an issue. And people like web developers are also harder to justify because they have an ongoing salary component. Whereas if you go and buy a supercomputer, if you have to throw it away, you're not going to have the union protesting or have to go to court or anything. You just turn it off. So the sort of issues that come up in terms of e-research is that a lot of our researchers are very good at their sub-discipline, but they don't necessarily know what tools are available or what a database could do for them, or what JavaScript can do, or what C++ could do, or various things, because they were trained as a lawyer or they were trained as a psychologist or whatever. People in the IT discipline are a lot different in that they sort of understand the fundamentals and sort of go, oh yeah, a computer could do that for me. And so I think it would greatly facilitate our research here if there was a pool of experts when you had this is what I want, and you could go and describe it to a bunch of experts in the area. What do I need? And then they might say, well, you need a web developer for 3 months, and you need an Oracle database, and you need 100 gigabytes of RAM and 16 terabytes of disk, and you need hourly backups and things like that. That's sort of things that we don't want to have to teach our lawyers or whatever about. The other problem that we face sometimes is that not all programmers are created equal. And some programmers are good programmers if they're working on their own things, but when it comes to interfacing with humans, they have some issues. I myself I think I can pick a good programmer from a bad one, but I haven't always done that. And I'm trying to convince the programmer they shouldn't rewrite all your code in C just because they like that, when it already works in another language, can be a problem. And a lot of our programmers go from contract to contract as we get soft money from various pools trying to keep them on. And this gives them no career structure and no certainty, and eventually they go and work for industry or something, which isn't good. And a lot of us are building bits of kit and hardware and middleware and software, and we get the grant to build it, but then there's nothing to maintain it. And even though the maintenance might only be 5% per annum of what it costs to build in the first place, there is no ongoing sort of money for that. And so we're not actually very good at sort of planning for the future, and it's partly because people don't want to hear about, oh, we need to keep this programmer on, but only need them a few hours a week, and the programmer doesn't want to hear that. The other issues we face is that if you have somebody who's written a software system for your research, if they're maintaining it, the amount of documentation they need is very different than if they leave the organization and a new programmer comes in, they try and understand the source code. So we're actually much better being able to retain our staff than we are cycling through programmers every year or two. And unfortunately, a lot of this e-research infrastructure is really hard to get money for. So if you write to the ARC and say, I'm going to train a postdoctoral fellow in the art of pulsar science, they go, oh, it's really good. And they'll write science and nature papers and so on. Whereas if you say, I'm going to create a database that's going to put the pulsar catalog online, it's just, that doesn't really sort of hit their buttons. But there are things like Nectar and these sort of pots of money lying around which are made for that sort of thing. And I think there was a growing realization over the last few years that that would be a good thing to invest in. Whether or not the government continues to invest in it or not is potentially a problem. So today we're going to see just a little various examples of e-research that are happening here, and hopefully that'll introduce you to each other. I don't really want to hear about why Lambda CDM cosmology has been transformed by your new tools. I mean, that's right to have maybe 60 seconds on that, but I really want people to emphasize, the kinds of methods that they're using, why it's transformed their research and why it might be useful to others. And we're also going to have some external presenters describing things like VicNode, which is a state-based system for storing data. And at the end of it all, we'd like some consensus about the way Swinburne should go about supporting e-research in the future. So at the end of your talk, I'd like you just to spend a little bit of time saying, what's good at the moment. We need to know what's good. Maybe it's the fact that the network's always up, or in fact that we had a power failure at Swinburne. The only thing that didn't crash was the network. It's amazing. The supercomputer here is pretty neat. Also, I need to know what's bad, but I don't want you just to bash ITS. I think ITS are constrained by certain constraints, and just because it doesn't suit you all the whole time, I don't really want to just hear a moaning. I'm more interested in, how you can't maintain your staff or because of limited contracts. And also, we're not the repository of all knowledge and wisdom here. If you have some good ideas, please tell us what you'd like to see. So there is no huge pot of money at Swinburne waiting to be spent on e-research. There's an organisation called QCIF, which is a sort of federation of universities up in Queensland. And one of the things we could potentially do is create something called the Swinburne Data Science Institute. We'd have a central pool of e-research experts that you could go to and say, I'm thinking of applying for a grant. What will I need to put in? How much would it cost? And it could have various programmers and database experts and stats gurus. But these people would all have to be funded. People like that could help us design hardware. And then Swinburne staff could go and get grants. And then when you get your grant, you just sort of knock on the door and say, I need a program for 6 months. They would sort it all out. This would be good because when you apply to a grant body, you could say all the staff are going to be provided by the Swinburne Data Science Institute. I need 50K in the first year and 20K in the last 2 years. And it's much better to have somebody who knows about the web and somebody who knows about databases and programming and hardware than it is just to have a single group hire one person and they have to know everything. I've only got 1 second left, so the other thing we could do is just outsource to somebody like VPAC or V3. That hasn't worked particularly well for us in the past. And at the very least, I'd like to think we could do an audit of who's involved in e-research here, but work out some budget numbers for what these people's staff retention costs are. Try and get some realistic estimates of what grants we're likely to have in the future to support these people, and maybe have Swinburne sort of underwrite salaries so that if you have a gap in funding, we don't suddenly lose all of our staff. I'll stop there.
Do you have any questions for Matthew while we switch over the talk? No.
One thing you haven't mentioned is teaching. Possibly an opening market under teaching in this area. Something that the Institute could possibly address.
Yeah, I think if we did have something like an identified brand like the Swinburne Data Science Institute, students could come here and learn about how to they could do a bit of computer science and a bit of maths and a bit of statistics and how you manage data. And I think that would be a great new sort of teaching stream. Whether or not it ever gets enough students to kind of justify it, I'm not sure, but maybe it's the big oil of the field. Big data is the big oil.
Any other questions?
Any other questions? Yes?
Steve Bowe. one of the statisticians around this place, and I just want to know where you see the whole data science going. I mean, a few of us here, there's, I know, 4 or 5 of us that are statisticians here. We consider ourselves statisticians, mostly working in health, but across the university, where do you see data science sitting, and whose responsibility is it to take charge of data science, do you think?
So the question was, whose responsibility do I think it is to, or is data science? I'm not sure is the honest answer. Maybe it should be my problem. I mean, what we really want to do is do good research everywhere, and I think there's been a growing realisation that without proper statistical analyses, your scientific output, and I mean science in a very broad term there, doesn't mean much. So, I'd love to have the statisticians in a sort of loose confederacy of the sort of Swinburne Data Science Institute and get people talking and helping people to do better research.
Well, we are doing that at the moment. We have got applied statistics, and we've been running a postgraduate masters for quite a few years, so we are out there and trying to help, but the problem is, I guess, it's been profile for us, and that's what we're trying to do in the next few years, is try and lift that profile and show people we are here. But one of the biggest problems we find as statisticians in this university is that the teaching load is ridiculous, and there's just way too much teaching for the number of people that we have, and that's what we need. We want to do more research and help people, but we're bogged down in our teaching, and I've got 3 units this semester, plus I've just been asked to be on a chief investigator on an NHMRC grant, so you just got to juggle so much. And what I'm saying, I guess, is we need more statisticians to help.
These are really key points, I think, to bring to the discussion. These are really key points to bring to the discussion, that these are the kinds of things we need to talk about.
This has been a Swinburne production.